Hello and welcome to the Potential Difference Research Lab. Today we are going to perform a definitive demonstration to prove the claims of infinite efficiency and energy creation. So we have a request here to perform some tests regarding the different performance of a conventional electric generator and a ReGenX generator under load. And the request calls for a physical replacement of the ReGenX generator with a conventional generator. And the beauty of the prototype that we have right here is that it has a conventional generator coil in it, and we're going to supply electric power to the load. And it has two ReGenX generator coils, and we're going to use those to override the conventional generator's counter-electromagnetic torque and its deceleration of the system. So when the conventional generator is placed on load, it's going to decelerate the system. Our prime mover, which is here, our prime mover consumption on the power analyzer, prime mover consumption is going to increase when the conventional generator coil is placed on load, and when the ReGenX generator coil is placed on load, the power consumption of the prime mover is going to be less than what was required to establish rotational equilibrium at no load on idle. So at rotational equilibrium, the power in the drive shaft is the torque times the speed, and at rotational equilibrium, the net torque is zero, and therefore the power in the drive shaft at rotational equilibrium is zero. So if we look at the criteria of demonstration 1, it calls for a setup of a conventional AC or DC motor. In this case, we're using AC, and a AC or DC generator, and in this case it's a AC generator connected to a load with power meters that clearly indicate the power consumption of the prime mover and the output power produced by the generator across the load. So these two meters here will be showing the power that's delivered by the conventional generator across the load, and we'll be able to observe the input power consumption increase to the prime mover on the power analyzer here. And when the ReGenX generator coil is placed on load, we will be able to observe infinite efficiency electricity generation when the power to the prime mover becomes less than what was required to establish no load at rotational equilibrium. If the input power to the ReGenX generator does not increase when it's placed on load, or is less than what was required on no load, then that's the definition of infinite efficiency electricity generation, and that will be obvious. And energy creation will be observed when the kinetic energy of the system, when the kinetic energy of the system decelerates, electromagnetic field energy is being created in order to perform the negative work, and then electromagnetic field energy around the ReGenX coils will be created, and it will be used to perform positive work. So let's fire up the generator and see what happens. So the first step is to bring the system up to rotational equilibrium, and at rotational equilibrium according to Newton's first law, additional angular acceleration or a speed increase cannot be achieved unless external energy is supplied to the system. In fact, when Newton's first law and the work energy principle is applied to the conventional generator's operation, and we observe that negative work is being performed, created electromagnetic field energy is responsible for the negative work as well. So currently our system is operating on no load at rotational equilibrium, and we're going to demonstrate the conventional generator, and we're also going to demonstrate negative work, which is being performed by created electromagnetic field energy. And in the description box, I'll put the video which explains how electromagnetic field energy is created inside all current-bearing wires, and how that energy performs negative work in conventional generators. Okay, we'll place it on load now. Okay, so our conventional generator is on load right now. We are delivering 10.65 volts. So we're delivering 9.69 watts to our load, and our prime mover consumption has increased to 188 watts. From a no load rotational equilibrium condition of 168 watts. So we'll place it on load again. Pay attention to the consumption by the prime mover. Right now it's 169 watts. So the conventional generator coil is delivering almost 10 watts to the load, and the input power consumption to the prime mover has increased by about 20 watts. So now I'm going to place the ReGenX generator coil on load, and on the oscilloscope you can see the load current sine wave for the the conventional generator coil. And when I place the ReGenX generator coil on load, the input power consumption to the prime mover will drop to a value that is less than the no load condition of 169 watts. So now we are delivering So now we're delivering 11.1 watts to our load, to our light bulb, and our prime mover is consuming less power on load with the ReGenX system than was required at no load, at idle, at rotational equilibrium. So right now, because the input to the prime mover is less than it was at idle on no load, the prime mover is actually supplying less mechanical power to the generator drive shaft than was required at idle on no load. So I'm going to put it back into the no load condition again, and then I'm going to try to synchronize the connection of the conventional coil and ReGenX coil so you can see that the prime mover power consumption literally obviously goes down instead of up. So we're at 168, 167, worst case scenario, 168 to our prime mover. Infinite efficiency electric generator operation would be observed if power is delivered to the load, but the consumption of the prime mover doesn't go up. And infinite efficiency is also observed if the consumption goes down. So once again, we're delivering 11 watts to our load. The power consumption of our prime mover has gone down, which means that the electricity is being generated at infinite efficiency. We can see the load current sine wave for the ReGenX coil in blue on the oscilloscope, and the load current sine wave for the conventional coil on the oscilloscope. And Now I'm going to place the second ReGenX coil on load. Now we're delivering 11.73 volts across our load. We're delivering 11.14 watts across our load, and our prime mover power consumption is down to 161 watts. So approximately an 8-watt prime mover power consumption decrease, and with a little over 11 watts of electricity generation to our load. So currently the speed of our system is 3,501 RPM. I'm going to place the conventional generator coil on load, and I'm going to measure the speed again. So the speed right now on conventional generator loading is 3,481 RPM. And what I'm going to do is I'm going to calculate the kinetic energy decrease of the system, and I'll put that in the description box. The kinetic, according to the work energy principle, the kinetic energy decrease of this system is equal to the work performed on the system, which is equal to the energy required to perform that work. And because we're not supplying any external energy in order to perform negative work and decelerate the system, the energy has to come from somewhere, and it's being created at the subatomic quantum electron level inside the current bearing wires, and it's being manifested around the conventional generator coil as an electromagnetic field energy, which is performing the negative work. So now we'll look at the positive work that's being performed by the ReGenX coils so that we can convert that to a kinetic energy increase. With one ReGenX coil, the speed of the system is 3,505 RPM. And with two ReGenX coils, speed is 3,509 RPM, and without the conventional generator coil, it's 3,523 RPM, and with nothing on the system, the initial rotational kinetic energy at our initial no-load speed is 3,501 RPM. So again, in the description box, I will calculate the rotational kinetic energy of the system on no load, and then with the conventional generator and then the ReGenX generator, and we will be able to determine the magnitude of work that's being performed, the magnitude of negative work that's being performed by the conventional generator, and the magnitude of energy that's created in order to perform that work, and then the magnitude of electromagnetic field energy that is being created in order to perform the positive work. And we will satisfy the initial requirement of infinite efficiency electricity generation with no additional power consumption from the prime mover when it's placed on load, and energy creation with the energy that's created and required to perform the negative work in the conventional generator, and the energy that's required, that is created, in order to perform the positive work. So okay, so the demonstration 2 is essentially the difference between a ReGenX generator and the conventional generator, and the requirement for the ReGenX generator is that the input power should fall to 0. So that condition has been met, because at rotational equilibrium, the input power to the generator, which is the mechanical input power on no load at rotational equilibrium, which is 0 watts, when the ReGenX generator is placed on load, the mechanical power in the drive shaft actually is not increased by the prime mover, but instead it's increased by the ReGenX generator. So essentially the input power to the generator on load should be 0, but in fact it's a negative number. It's less than 0, and so we have satisfied the criteria of demonstration number 1 and demonstration number 2. And what I'm going to do next is I'm going to run prototype number 2 which is in the back there. And I'm going to basically perform the same tests, and we are going to operate the system in ReGenX mode, and we're going to operate the system in conventional mode. And we'll be able to observe the differences there as well. So, thanks for viewing, and cheers for now.